Welcome, everyone, to another episode of It Depends podcast. Streaming data is taking over, and it is expected that at some point we will see streaming data become sort of the de facto way of ingesting data. And whether it becomes big and when does it take over, we will listen to today from my good friend, Alok Pareek. He is a co-founder of Stream, and Stream has actually, interestingly, this is the 10th anniversary of Stream. I've had a few occasions of celebrating the 10-year anniversary on this podcast, such as Amazon Redshift, Snowflake, Hotspot, Apache Parquet. And today, I am delighted to have Alok join us on this podcast. Alok, thank you so much for taking time from your busy schedule and joining us.
Sanjeev, it's great to be with you, and I'm delighted to join you and have a good conversation. And thank you for the 10-year anniversary notice as well. So as you can see, we're in great company and out to change the world.
Yes, absolutely. So, Alok, let's get started. It'll be great if you can give viewers an introduction to your background and what has your journey been like?
Sure. So, Sanjeev, as far as my background is concerned, I mean, you mentioned currently I head up all of the product areas at Stream, and I'm one of the co-founders here. I started in data management, quite a while ago. Where earlier on I started my career database development team, mainly concerned with areas like database recovery, fast data movement from one database to another, from databases to data warehouses, etc. And then I ended up joining a company called GoldenGate as a software architect, and that was in the heterogeneous database replication space. And I became their chief technology officer. And that was a great product, which ultimately Oracle had acquired. And I spent a few years after the acquisition at Oracle, primarily leading the data integration portfolio. And that included not just Oracle GoldenGate, but products like ODI, which is the ELT product, and then a few data quality products and data services products. The last 10 years, obviously, I've been busy, building Stream and bringing that to market and doing some pretty exciting things in the data management space and the streaming space in particular.
So it's interesting. You were at Oracle in early 1990s, and then you moved to GoldenGate, and then came back to Oracle when it got acquired. So you've been doing streaming data for 25 years now or more?
Yeah, absolutely. I guess time goes by so fast. But yeah, in the Oracle database, I was primarily taking a look at redo generation and recovery, and a lot of that, the changes that occur in data blocks and into the actual tables and so forth get recorded as write ahead redo change vectors. And so that was really my area of responsibility within the Oracle database. So from there onwards, mining that and making the changes available for a variety of interesting data applications. So have a pretty long history with streaming. In fact, in 2009, I was beginning to sort of talk about not just mining, which is sort of the whole change data capture set of technologies, but trying to integrate that with more complex event processing type of technologies, because the idea of in-flight analytics was always something that was interesting, and in my discussions and experiences with a lot of implementations in database application, the whole area of in-flight analytics tended to appear. And so I started paying attention to that, and that's what led me to Stream ultimately.
So this is interesting. I want to dig deeper into what you just said about in-flight analytics on streaming data. When you were at Oracle in 2012, Oracle already had acquired GoldenGate. You also mentioned you were working on ODI, which is Oracle Data Integrator, which is the ETL. What prompted you to start Stream, and what was the gap that you felt needed to be filled?
Yeah, I'm glad you asked that, Sanjeev. And I think that is probably like, a really one of the most fundamental questions about like Stream and its existence and what we're trying to do in the industry. Maybe I'll start off with an example. So GoldenGate itself was primarily a database application product, which had multiple use cases in high availability and disaster recovery, zero database migration, data warehousing integration, things like that. As we started working with some of the very large environments in the world, one of the things that was, kind of obvious was there were inherent application characteristics like workload spikes that might actually, start appearing and manifesting themselves as lag between, if you view let's say, replicated systems as a source and a target or multiple targets, typically there's a queue which is disk-based that stores all of the changes that are being done at the source, and then you're going to propagate that. So this is typically the distribution queue, if you will. At that time, I distinctly remember, Overstock.com was very ahead in their journey. They had a massive Teradata implementation where they had recommendation engines in the mid 2000s, and they were trying to keep a recommendation ready when someone just logged into the website. And that was an application that pulled in information from the operational Oracle database and the Teradata system. And then GoldenGate was the bridge between them at that time. And oftentimes, there would be just a lag between the source and target. And they used to look at this as a P&L problem and say, hey, what does this lag mean to us? We have thousands of suppliers that are busy uploading inventory data, and we want to see whether, perhaps one of the attributes in the data potentially has poor data quality, where people and there was a specific example where a price got mislabeled, which the database constraints happily were satisfied. However, if you see an item that actually is a tenth of its price, then that leads to sort of an interesting spike in traffic, which is what the disk-based lag manifests itself as. So that led to the idea that what if there would be a way to analyze the data that's in flight, right? And that's where this concept of streaming ingestion and streaming analytics started to at least blend in my head at that point.
I see. So that's pretty unique that you are doing ingestion and analytics, because that seems to be such a popular thing these days. Kafka talks about it, and all the cloud providers talk about it, but it seems like the stuff that you got into preceded some of the current technology, like even Kafka. Would you say that you?
I would absolutely stake that claim, Sanjeev. And if you think of what Stream does, right, we are trying to bring a unified service to the market, which solves two problems. There's the problem of real-time data streaming, real-time data integration, and then the streaming analytics on top of that. And that's what we call the unified service. So if we take a look at how traditionally this problem was being solved, and then with the evolution to maybe some of the current players, traditionally you would have to have some sort of a change data capture component. You might have an ELT type of component, and then you would have a complex event processor. If you wanted to actually scale it, then you have probably some sort of an in-memory grid technology that would actually, cluster this stuff together. And then again, if you wanted to, move this somewhere to maybe a data lake or maybe to an analytics system, you would have to again have some sort of a integration layer. So you're dealing with a number of different products here. And so that was the original way people would solve this, potentially at some of the vendors earlier, such as IBM and Oracle and all the ones that actually had a combination of these interesting data management products. In 2014, we published our own IP where on distributed event pipelining, where we introduced a number of these concepts, which included the ability to get data from using change data capture components from databases, from messaging systems like Kafka queues, from file systems, from files that are continually being written into, as well as data coming in over, let's say, the web through protocols like HTTP, and then trying to analyze this using a stream processing technology. And so the constructs there, for example, of the integration, along with what you would expect in the stream processing engine. Obviously, there's a whole query processing layer, along with all the optimizations of trying to support the incoming streams, trying to join streams and correlate streams, and then also with the semantics of streams, with temporal windows, session windows. A lot of that was this predates Apache Flink, by the way. At that time, the only at least distributed streaming engine around was Apache Storm, and the Twitter guys internally had the Heron project. But so we built our own because Storm was about 1/10 of the speed that we wanted. And so we published that in our IP in 2014, and that patent was granted in 2017. And many of these concepts that at least the Kafka community has introduced, including KSQL and Ktable, and these have come much later. Not to mention, then of course you still have to put all this stuff together yourself. So we really thought of the problem from an end-to-end perspective. Right? We are not sort of looking at this coming in from a technology point of view. We're looking at it from the point of view that if you have event streams as part of your enterprise, then how do they flow? How can you standardize them? How can you analyze them in flight? And how can you deliver them at the right time, at the right place to make the right decision?
I see. Got it. I am very interested in seeing how this all comes together. Macy's is one of your projects. So can you talk about from a business point of view, how does Macy's, for example, benefit from your architecture?
Yeah, that's a great question, Sanjeev, and they're a great customer of ours, and we talked about this publicly as well. So I'm happy to shed some light there. So if you a few years ago, they started on their journey of digital transformation, and their CEO has had multiple conversations around that. The entire idea was that their vision was they would actually have a common shared bus that would sort of unify, different events that are coming in from their inventory system, from their product system, from their catalog system, and from their pricing system. Now, if you take a step back, how they run their applications, they're heavily invested in many of the platforms like DB2 mainframes that might be running all these traditional applications for inventory management, pricing, etc. The newer ways in which they wanted to reach out to their users was through an omni-channel experience. Mm-hmm. So up until Stream was in the picture, if you came into a store, to a physical store, then obviously there's a mainframe as a system of records that keeps track of the current information. If you come in from the website, then you had a digital journey. And they really wanted to mix these two things, because increasingly their vision was you may start your journey on the digital channel, but you might end up physically in the store to actually do an in-store pickup. So you can sort of see where this becomes a little complicated between the storefronts and the actual physical stores. So that's where they wanted to keep the information between, every time you consume any inventory, they wanted to publish that in real time to the storefronts. So they, at that time, when they talked to us, they were working with Google Cloud, and they had a number of different endpoints there, including Google's own distributed spanner system, PubSub as the queuing system, and storage. And they wanted us to deliver the actual data that's in the mainframe for these various siloed, fragmented applications in real time into these endpoints. And so that was the deployment that we started on with them. And it was fantastic working with the Macy's teams, and end to end. So you can imagine that someone comes in onto maybe just an iPhone or Android device or whatever you have, or a website, and you can try and browse the catalog. You could try to see, how many items are in stock. So, the end-to-end latency between the true system of records and, the system on the cloud needed to be less than 200 milliseconds. Oh, wow. Because otherwise, and that was a pretty big deal. And we, in fact, that's in production, and they tested that on Black Friday at their peak throughputs, which was close to 7,000 transactions per second. And we were able to keep the latency under 200 milliseconds. And my final point there, Sanjeev, was one time I remember we ran into some sort of an issue where the latency kind of creeped up to a second. And so our teams met with them and we sort of discussed it. And once we figured out what the issue was, I did ask them, like, why do you guys care so much that it's 1 second? I mean, between 200 milliseconds and a second for this type of a use case. And they said that, that matters quite a bit. That exactly results in sort of either underfilling or overfilling the order, and customers tend to get very unhappy if they've just purchased something and then you end up telling them that, oh, by the way, that item is no longer in stock. And that's one of the most negative experiences that can be felt by the customer. So this overall was part of the Macy's journey. And, as you look at their results, clearly they have done really well over the last couple of years. The public numbers, I saw them on MSNBC as well. And just a few weeks ago, I heard that they had about 400 additional suppliers that were going to use the Macy's digital platform, where the Macy's was the one actually that was going ahead and serving as the order management and inventory management application, and the end-to-end products were obviously being managed by their partners. So it was a very successful implementation, and that is in production today.
Got it. Very impressive. Beginning of this podcast, I mentioned how we've got batch and streaming workloads, and there's this whole notion that streaming will overtake batch. What are your thoughts on this? What percentage of batch versus streaming today, and what do you see in future?
Yeah, that's a great question. So we see almost every engagement that we're in. Obviously, there's the legacy implementations, typically, your classic information factory with ETL being the predominant way in which people are moving around data between different teams and so forth, right? So we do see a lot of batch workloads. However, it's very interesting that almost 100% of the discussions that I've had, at least, with these large enterprises, they do have some sort of streaming as well. Now, oftentimes they may just go to the system of records for that real-time analytics if they have to, which is, of course, super taxing and quite intrusive on the actual operational system itself, which is what leads them to actually then talk to us. So, now if we sort of take a look at how, the modern data stack is evolving, and some of the, concepts around, and I know you have talked about the data mesh, Gartner talks about data fabric. A lot of that has to do with flexibility. A lot of that has to do with, making sure that, the people who really, know the data the most can offer that as the product. And there's this ownership and domain ownership aspect of it. So the way, this is sort of evolving is, you're some team and you are fast, you want to move and deploy, some sort of a data product. So number one, you want the flexibility to quickly, choose your own infrastructure. So you may pick, maybe one of the cloud environments and an endpoint, which could be SQL, NoSQL, time series, whatever endpoint you might pick for your own application. And then you quickly want to make sure that all of the business data starts moving there. Mm-hmm. And now when we come back to the question about batch versus streaming, if you were to write a new application today, chances are that, if you had an option and a very efficient way to grab the data streams, you wouldn't really care about batch. And I want to be a little bit deliberate here because, there's always confusion in this area. Mm-hmm. Batch doesn't just, mean that, hey, I'm going to come in every day at midnight and then, sort of move the data. And streaming doesn't mean that I'm going to just continuously capture and continuously apply. Right? I think there's a way to think about this from an end user's perspective, from a consumption perspective.
I see. How should we think about batch versus streaming?
So I think that, so number one, let's agree that, and I do believe that more and more that latency window for modern applications is shrinking. Only because, you have other partners that are dependent on you, other business services that are dependent on you, and your consumers actually want to get real-time information, increasingly. So this whole 24 hours old message, if you're, ordering something, or if you're trying to, if you're involved in some sort of a customer experience, or even if you're managing an operational environment and you get notified of some alert 24 hours later, that just seems antiquated in this day and age. So then let's talk about the fact that why can't batch deliver that, right? So as you know, on the batch side, if your data sources are producing more and more and more data, their job really is to make sure that at the best price performance, that throughput is well behaved under the SLAs for that system. Yeah. So all of a sudden, if you pound that with extractions for batches, that's not going to actually work. And it's going to start interfering with the actual application workloads, the application characteristics. That's the problem there. So the way I would think about that is, well, let's detach the batch from the way in which you're collecting the data. Make that more of a change data capture approach. So that way the changes are being, sent. So that then at a simplistic level, as you're trying to make that available for downstream systems or for consumers, they have the choice. Some of them might want to consume that right away because they are trying to have real-time applications, for example, in the Macy's scenario. But let's say that you are trying to build some models and it takes you a finite amount of time, despite all the distributed computing in the world to build that model. It may take you like 2 hours or 3 hours or 4 hours. Do you have to actually give it the signal every single time as an event? Not necessarily. And I think that's where you start making choices.
So basically, what you're saying is that from the data producer side, change data capture should become the de facto way of bringing data in. But then depending upon your use case as a data consumer, you may consume it in near real time or batch.
Absolutely. Absolutely. I mean, those are just valid choices depending on how if for example, I am interested in getting, I can actually give you a real life example. I mean, we're, close to a 300 people company. We work with our cloud partners. We have billing that goes on all the time. So if I want to see my own consumption, it's interesting. Do I want to do a pull-based real-time report? Once in a while on an ad hoc basis, I do, but typically they are sharing that with us on a monthly basis. Would I like that to be daily? Yes. So you see that those 3 points are reflecting how businesses are beginning to think about it and where the world will go. Because ultimately on an ad hoc basis, I do want that in real time, but I'm happy if it's at a day granularity because chances are I'm not looking at it constantly as an executive in a company. And I think that sort of reflects sort of the choices that different people have. So a lot of times what happens is, traditionally different teams at these technology companies or business, just in businesses, they think that if they go to streaming, it's more expensive. That is no longer the case, was my point. And repeatedly what I've seen is, there are different jobs that run on the system. So they're already incorporating the cost of running those within the actual, when they scale the actual system itself. So if you simply move that to more of a streaming model, all of a sudden, a lot of those, evil or ugly batches just simply disappear. And only the ones that truly potentially, want that, let's say once in a while, you want to do a historical load, then of course it's fair game to come in and plan that at the desired time period. But in general, if there's a nicer way, efficient way, low-cost way, non-intrusive way to grab the change data streams, ideally that should be your preferred way of obtaining them. And then you can actually buffer them and apply them. And that's the choice that we give, for example, to our own customers, where in the streaming analytics engine that we have within the pipeline, you could actually have a data window so you can buffer it for an hour or for a minute, or you could actually produce a file every hour or every 3 hours or every 24 hours, and you can consume that if that's how you want to consume it. Most people, it turns out, are not consuming it that way. They do want to, apply that in real time.
So in order to do that, so when the streaming data comes in, because you're giving the consumers the choice of when they want to deal with it, so you are persisting that stream at that point, correct? So what is that persistence store where you're...
Yeah, great question. So because we want to actually effectively decouple the publisher and the consumers, then you do need some sort of a persistence-based mechanism there if you're not going to consume that right away. So there are two ways to think about it. So the first thing, of course, is when you persist it, we actually ship with Kafka. So that actually serves as the backend, and we have completely abstracted the stream concept from the backend persistent concept. So an end user in Stream simply can create a stream through, let's say, the UI, or through our command line, or through a RESTful interface. And then if they choose to persist it, then we actually create the Kafka topic, so they don't have to manage that piece of it. The second piece, as they're consuming it, we're bypassing it and completely are in memory. And so we use a high-speed messaging library there called 0MQ. And so we directly are pushing that out. Now, in this case, of course, the consumers better be ready to consume that. Now, for some reason, if we, there's some sort of an interruption there, then we can go back to the source and we maintain, checkpoints in the source, and we can replay those streams so that, it can be consumed. To the specific question you had about like decoupling them, then of course you would have to actually persist that, in which case different consumers can consume that at their own speeds. And so we use Kafka as the backend for that persistent stream.
I see. Got it. So, Alok, I remember there was a time when you were telling me about how the human brain works when we think about streaming and batch. You're a keen reader. I know you read a lot of anthropology kind of books, if I may.
Sure.
What's your theory about batch and streaming from a human aspect?
Yeah, that's a great question, Sanjeev. And I think that the analogy that I was in our previous discussions is, when we are taking input, like there's all kinds of incoming sensory input that we are taking. And so the general idea there is to make sure that, for my immediate actions, I'm aware and I can process streams so that I can maximize my own efficiency, survival, and so forth as a human being. Now, imagine that, you had the incoming streams coming in and you decided that you want to analyze that for all possible purposes that you could think of as a human being, meaning all your relationships, personal or professional, or historically going back and adjusting things all the time. So that may not happen in real time. And I think that was the point that I was making, that what you want to do, similar to what we just touched on, is take the incoming streams and make sure that, for the immediate action, you have all the relevant information. And then, other information, you're still taking this information, but you can condense that at a later time and then incorporate that into sort of your larger outlook in life, which may be that, hey, what's my experience in this specific context? And that becomes habit and so forth as you go on.
This is fascinating because I've been reading about this topic, how there are two ways of ingesting and reacting to a sensory input. One is reflexive and the other one is reflective. So reflexive is when you're not thinking about all that has happened, you're just reacting to the packets as they're coming in, and you may be locked into a very narrow analysis. But reflective is how you should aim to be, because then you can rely upon like a bigger set of knowledge base.
Excellent point. Yeah. And Sanjeev, by the way, I think that's a great way to look at it. And people always ask me, like, will streaming analytics ultimately just dominate, and do you not need batch analytics? And that's certainly not the case. I think when we work with a lot of our own target endpoints, such as Snowflake or Google BigQuery or Azure Synapse or Databricks in Delta Lake and so forth, or Oracle Exadata, when we look at those systems, typically they are concerned with the problem of saying, hey, I want to like go in and run a churn management report for the last 90 days for a set of incoming customers. Mm-hmm. That is a very different workload. That's a very different type of analysis, which is like more of the reflective mindset, if you will. And then, the immediate ones are all about, hey, someone just logged in right now into my website. What is it? How is it that I want to communicate with them? Am I giving them the best customer experience? And are my operational teams leveraging all of the, touch points that they're having with me as an entity, right? Those are all the streams that need to come together for me to truly offer up a unified view, a customer 360, or a personalized experience for that specific use case. And I think both the batch analytics and the streaming analytics are, they make sense. They're here to stay. I think that today, a lot of the streaming analytics workload tend to get pushed onto the end system. But I do think that that's going to slowly start coming into the pipeline itself. Just as you and I were talking that, if I'm getting a piece of information and if it's more relevant to me, then I'm not going to go wait till tomorrow to act on it. If I can process it along the way, then that's the best way to process it for the in-flight analytics purpose.
Right. As the technology gets faster and more advanced, we can then handle these complex processing closer to the time the data comes in. So we've talked about streaming analytics, streaming ingestion. We've got ETL, ELT. We talked about change data capture. The market space that you're in, what category, is there an umbrella term for that category? And what would be its target addressable market or TAM?
Yeah, that's a good question. And that's one of the harder ones because, when you're trying to define a new market, usually it's tough to just upfront go coin a term. But I think that these concepts are converging into what I call a broader category, which is streaming. I don't think everyone's caught up yet. Mm-hmm. So traditionally, if you look at how I would characterize the TAM here, you could think of the data integration market as such, where maybe batch tends to dominate. And then there are streaming workloads like we talked about. And that itself, if you go look at some of the reports from the analysts like Allied Market and so forth, I think by 2028, it's supposed to be a $50 billion addressable market. And then streaming itself, I read another report from Markets and Markets, and they were saying that it's about another 28 or so billion by I think 2026. So I think it's a huge market here. The different pieces here are the streaming ingestion and streaming storage. So you could see that there are technologies there where you may just want to come in and store the stream itself. Then there's the streaming analytics market, right? And then there's the streaming apply market, or which may be notifications, alerting, or potentially deploying business intelligence applications on the streaming analytics engine itself so that you could have real-time dashboards. And so, overall, this market is just, it's growing, at a healthy pace, 7 to 10% CAGR. And I think that it's definitely by, 2028 or so, this is a pretty significant, $70+ billion market.
So I see, there are all kinds of products we come across these days, ClickHouse, Rockset, Materialize, Druid. I want to ask you a question about these products and how the space. But before I go there, something that intrigued me with what you just said was you're seeing the space growing. At the same time, we are hearing that the market is starting to slow down. Tech spending is going down. What are you seeing in the market in these economic times?
Yeah, at least Sanjeev, if I depending on these times definition, if I start from maybe the pandemic,
it's all of 2022. So just
2022. Yeah. So I think during the pandemic, of course, there was it was just like a crazy growth that we have seen. More recently, I think if anything, there might be a slight degree of caution in terms of people trying to figure out where they want to emphasize their spend. But from a transformation perspective and cloud modernization perspective, I think we're seeing phenomenal growth in those markets. Particularly when for us personally, Striim is we're a very attached business from that perspective to some of the partners who are the hyperscalers. And I think the cloud movement is very real. And oftentimes, the way to actually go start using something in the cloud is to make sure that the hybrid bridge exists between the legacy investments that you've made along with the new investments that you're making. And so we're a critical piece of that infrastructure, and streaming at large is a critical piece of that infrastructure. So I think that this space definitely has a bright future. If anything, I think what we're seeing is a lot of batches are slowly beginning to get converted onto sort of the newer paradigm. And you see a lot of the investment in this whole modern data stack and those kinds of newer phrases.
Yeah. So I mentioned some of these companies that purposely built for doing real-time analytics on streaming data. But then even the traditional data warehouses, cloud data warehouses like Snowflake now has streaming ingestion, BigQuery, Redshift. So what is the role of Stream in this landscape of cloud data warehouses, analytical products with real-time? How do you see Stream presence?
Yeah, that's a great question, and I think from if the differentiation that at least that we want to bring in, that Stream wants to bring in, is number one, we don't want to ignore database streams. Right? If you take a look at a lot of the technologies and the stacks, that you mentioned, Sanjeev, in your own question, typically, I think the connectors that they provide might be to maybe weblogs or to file systems in some formats. However, most of the critical data, most of the transactional data, most of the business data tends to be in pretty critical systems like Oracle, whatnot. So making sure that the database change streams are addressed and handled is a key piece of this, because that's where a lot of the high value data comes in. How are you going to know your customer, right, if your CRM system is not talking in real time to your analytics system? Yeah. Right. So it's one thing that you can get, the clickstream data that comes in, but unless you actually correlate that with your business data and start taking advantage of that, you will never actually be able to embark on the journey of true customer 360. And that's really the main point. So with Stream, because the legacy here has been that we want to make sure that database change streams need to be a first-class stream within the overall streaming ecosystem. We are very different than just maybe Kafka vendors, or very different than just pure data warehouse vendors who might otherwise have APIs or interfaces, but they leave the product-oriented view of that world up to people like us, which is great for us because that's where we specialize. Right. And then we want to make sure that we partner with them on the batch analytics part of it, and also on the near real-time analytics part of it. How I see it evolve is, if you're truly trying to do window-based analytics, push-based notifications, then I think that logic is going to start seeping into the pipeline itself. And that's where you will see other players. I think today we happen to be in a sort of the leading player here from an innovation point of view, in the sense that we're the first ones that have fused the stream processing engine within the integration pipeline. That is a big deal. That's something new. That's what we're bringing to the market. That's why Stream exists in the industry, to solve that problem. So we are pushing the bar ahead on real-time data integration by actually having streaming integration be sort of fused into that same pipeline, and that's the intelligence part of the Stream platform.
And so there's an infrastructure layer, which is the actual transport, and then you said you bring the product knowledge on top. Is that the schema? Is that like the SAP schema, let's say, and that's a source, but the target happens to be Snowflake, so you can handle the schema mapping? Is that how we should think about it?
Yeah, absolutely. So that's just one of the things that we do, right? If you take a look at some of the components from an end-to-end perspective, then we invest heavily in sort of the in points and the out points.
I see.
Right. So those are the actual adapters that talk to these end systems. And when we talk to them, there is a phase of schema discovery. So we actually grab the metadata, and once we start getting the events, then we can actually represent them in a generalized fashion, and then we take care of the mappings between the source and the target, so to speak. And in addition, then there are the concepts like, hey, how do you actually create the schema in the first place? So that's part of the automation that we provide. Then if the schema actually changes, right? So for example, on a table, you might, expand the data type, or you might actually add another column. So those things actually get applied. And we offer very flexible choices there, by the way, because this heterogeneous schemas may or may not be compatible. So if I'm trying to take data from, let's say, a Postgres system to, let's say, Rockset, whether everything makes sense or not from let's say you may have partitions, sub-partitions, hash partitions, range partitions, and so forth. What do you do with them if the downstream system doesn't support them? So then within the actual components of the platform, the end user can configure that to say, hey, go ahead and ignore this, or go ahead and first go apply this into a schema registry. So those are the touch points that we have with these third-party systems as well. And that is, so we manage all that, right, for the end customer. And that's where, you start to, Sanjeev, just appreciate the complexity of where I see, and these are partners of ours, but I think they tend to oversimplify things by saying, oh, I have an API. That doesn't mean much, actually. If you simply have an API for data ingestion, right, you still have to worry about the fact that somebody needs to manage the schema, like you're saying, or mappings, like you're saying, or evolve the schema, as you're saying. Or if the pipeline breaks, where do they start picking up things from in terms of state maintenance? What happens if you want to parallelize the workloads? What if there are, or in a CDC workload, you may have orders between the same key in terms of an insert followed by an update. So you can arbitrarily parallelize that. So how do you do, read aheads of the queue and make sure that you can partition them into proper batches? There's a lot of optimization that goes into those algorithms. And that's where our partners are not investing in those areas. They're just providing the API, which of course we cleverly use to apply and educate them and learn from them to see what is the best API and how do we evolve this.
If I didn't have Striim, then I would need to make sure that I'm doing the data type conversion, the ordering, the partitioning. I'm handling that from source to target. And then I also need a separate infrastructure for doing streaming analytics. But with Striim, you get sort of this highly configurable package with pre-built, the lower layer has already been handled. You can then check boxes and say, yes, I want this, ignore that. And
that's right.
I see.
That's right. And a very simple example might be, let's say if you have orders that are coming in, you want to get orders onto an analytics system in Azure for, let's say, analytics as an example in real time. Then along the way, if you want to say, hey, if I see that somebody was particularly having problems with an order. So let's say, oftentimes, on the web page, you may click it again, and you don't know what's going on. That whole experience that we have as a user, could you actually digitally track that in the pipeline? Of course you can. If I just have my web streams coming in from my order management stream, I can, through a session ID, go ahead and join those things and actually get a true picture. And that's innovative. That's something new that we're trying to bring to the market.
Very nice. And how do you handle security on the streams that are coming in?
Yeah, so great question. So from a security, we're obviously, our DNA is from databases. So we do have, all of the, so at the back end, there's a metadata repository, which keeps track of all of the objects that we manage in Striim. Things like streams, windows, data sources, data targets, caches, external caches. Then we have, things like alerts and so forth. All of those have role-based authentication built in around them. So there are permissions and privileges and roles. And so you can actually, hide streams between different users. So it's not like once you create a stream, everyone can get access to that. It's controlled very carefully. So that's one layer of the role-based authentication that we have. And then of course, overall, we support, anytime data is in flight or it's on disk, there's encryption around that. And then we also have carefully in the product integrated with, third-party key management services. So within Striim, Sanjeev, there's a first-class construct called a vault. So you can actually come in and type in create vault and give it a configuration and a vault spec. And that spec could actually map to, for example, Google KMS or, one of the other cloud providers, key management systems. So that's a layer of security that we have. And then of course, per component, we have our own salts so that we ourselves are not able to look at all of the data that is going through the Striim, the Striim pipeline itself. So these are some of the various areas. And also by the way, we just did a massive compliance on SOC 2. So that we're officially SOC 2 compliant now because we offer Striim is available as a managed service in multiple clouds. So we had to go through that process as well. And so, we're pretty excited about that. And we have some of the largest companies, largest airlines in the world using us in a managed services fashion.
So what I find fascinating is that you've opened my eyes when it comes to streaming, because to me, streaming was like, I didn't realize that streaming is such a first-class citizen in your case, that you got create stream, create vault, you got all these integrations, you got persistence, HA, I'm sure, performance enhancements. So basically, Stream becomes like the way we think of a table. Yeah, Stream is a first-class citizen.
It is a first class citizen. Yes, absolutely. And ground up, Sanjeev, we designed it that way because I think one of the challenges that, when we started Stream was, why is it that complex human processing is such a niche area?
Right.
And people have a hard time understanding, how do you program streams, but they're very comfortable when it comes to a construct like a table.
Yeah.
So we wanted to make sure that, as we don't leave and say, oh, well, here's a new set of users now.
Yeah.
What we wanted to do was make sure that the legacy investments are protected, and there's a way to bring the users who are working with these systems within an enterprise and how events flow to modernize that experience. And that's where, I think the repository and all the metadata, the definition of the streams and their types, the definition of the data sources and the targets, all of those are actually tracked in the MDR. And there's version control around it. There's metadata management around it. There's lineage around it. Those things we have thought through as if the database guys would actually think about that for tables and stored procedures and packages and all of the views and so forth.
Yeah, very. And how many connectors do you have now? And can end users create their own connectors?
Yeah, so a good question. I mean, the way we invest in connectors, obviously, like I said, the database change streams is a big area of investment for us because we want to make sure that your ERP, CRM systems, healthcare applications, your order management applications, billing, telco applications, they all typically have an underlying database. So if you really want to get streams from those, you need to support change data capture. So clearly there's a heavy area of investment beyond kind of the open source type of technologies that exist in the market, because we want to make sure that the enterprise features around them do get support. Then, we also support queuing systems like Kafka and so forth. And then all of the file systems like S3 and, just regular file systems. And then data coming in over, HTTP or TCP or UDP. And then increasingly Salesforce and all the applications. So these are all covered. So if I were to look at a combination, it would probably go into tens of thousands of topologies, so to speak, because we also tend to invest on the system that we connect to. So you can actually, again, talk to storage systems, to queuing systems, to analytics systems, to messaging systems, and to file systems, or directly talk to applications. For example, we have a Salesforce writer where you can actually deliver data, believe it or not, from an analytics system once you condense it into an application. And that's sort of this whole new thing that, for actionable insights that people are beginning to talk about, like reverse ETL.
Reverse ETL, wow. Okay.
That's right. So we're investing pretty heavily in those areas, and as we listen to our customers and to our partners, and we prioritize the ones that are sort of bubbling up to the top of the food chain, so to speak.
Right. So Alok, there's so many questions. I have literally, we can talk about performance, backups. There's just so many intricacies that come in the picture, but we won't have time to talk about all of these. So I'm going to ask you one last question about the product before we move on. What are some unique use cases that surprised you in how Stream is being used?
Yeah, good question. I think in general, from a streaming perspective, because at least we had such a holistic view on streaming, right? From ingestion to storage to analytics to application to visualization, right? All those things we thought through. But I guess if there's one thing that surprises me is oftentimes people will use this for streaming, but they'll still have like occasional batch workload, and they'll be like, oh, can you just go ahead and load this table every day for me at 8 a.m. for example. Right. And so we do have a component that we haven't touched on today called Open Processor within Stream that, end users are free to program themselves. And so we have a number of interfaces there, and, you can actually take that and go ahead and code it however you want. So that does suffice. So that's one thing that does come up, periodically. And one additional thing I want to touch base, I think you asked me a question, which I think I forgot to answer, which was about, can end users create their own?
End users create, yes.
And so there is a publishing API that's available currently. That's a Java-based API. And that's available for end users to publish data into Stream, so they can link in with that. And we are working on our own SDK so that all of the knowledge that we have collectively, we can have at least our internal teams, like our field teams, start building newer connectors there. And ultimately, that gets generalized to we have to think through how we ship that and so forth. And then there's plans on the roadmap to make that available for our partners and then ultimately users.
So if I may summarize from what you just said, is that today you have multiple ways of interacting with Stream. You mentioned you can go configure through a user interface. You can write your commands through an IDE, like create stream, create wall. You can use API. And what's on your roadmap is an SDK, which is coming out, which will allow end users to create their own connectors.
Yeah, ultimately, in the first cut, Sanjeev, we are targeting our own partners and our internal teams, and then ultimately, and the only reason being, sometimes I want to carefully guard this thing between where does a sort of a data pipeline engineer's role end versus where does a systems engineer take over, and having those two together sometimes can be a little bit challenging. There's a whole session that we can get into around that, because oftentimes, Sanjeev, like if you talk about getting data from external systems, let's say a database, they might have interleaved operations prior to transaction commit. So you have to carefully manage those and make sure that there are some interesting death scenarios and failure scenarios you have to handle there. And encoding all of that so that the end-to-end experience is super manageable, super easy, super automated in an SDK without having too much knowledge sometimes can be a little bit harder. So in the easier scenarios, like getting from data from files and so forth, I think that's not much of an issue. But when it comes down to some of the nitty gritty in terms of core change data capture with these interleaved operations, and that may have dependencies on external log artifacts that people might have backed up. And now what do you do as an end user? I think that becomes a little bit more complicated. That's why I think for the end users, for these CDC cases, we want to make sure that we provide an out-of-the-box, simple experience, and we don't want anyone to think about that, because you do tend to get into those systems level issues very fast, and that can get complicated.
Right. So Alok, we have a few minutes left, so I just wanted to ask you a few questions about like a different type of question. Who came up with the name Stream, and why the two I's? Because every time I tell people about Stream, I'm like, it's STRIIM pronounced as Stream. So what's the backstory here?
Good question. I mean, the simplest way is that there are two eyes that we have, so we can see better. So two eyes are always better than one eye. And jokes apart, they do stand for something. So the first I stands for integration, and the second one stands for intelligence. And so the intelligence is the complete stream processing engine that we talk about, right? Where you can actually go and express your own continuous queries and your SQL logic, or even your Java logic within the platform, so that you can actually go ahead and start getting insights and analytics on top of the data that's moving. So the moving part is the integration. The second part is the intelligence. That's the backstory behind the two eyes.
Very nice. Who came up with the name? Who are the other founders?
Maybe. So Ali, of course, is the CEO and my co-founder. He was also the CEO of WebLogic, and then the CEO of GoldenGate, which are both constitute a significant part of Oracle stack. And then Steve Wilkes and Sami Akbay are the two other co-founders. And so I don't think there's one person that came up with it. I think collectively as we evolved, I think we had a bunch of different choices, and I think this one evolved as the ultimate winner.
I see. Very nice. I was asking because I've also recorded Apache Parquet 10-year anniversary video, and in that there's a whole thing about who came up with the word Parquet, and it's but we won't go into that in this video. That's a separate video. But I want to ask you, Alok, just two last questions. In the process of going from like deep engineering into running a company, what are some of the lessons learned that you want to share with the listeners, and how should we be, thinking about our careers, our future, and handling challenges?
Yeah, good question. Of course, I do this because I enjoy it. So I'll share with people that if you really believe in something and if you're passionate about something, I think that's a great indicator of your own success. I think that is what I've learned along the way. that believe in what you really do and be super excited and passionate about what you do, because that feeds into your success. In terms of the journey towards being a founder, I like all the engineering aspects, and if you enjoy those, the culture at Stream we try to do is to actually have that engineering culture very ingrained, so that everybody who comes in, not only are they an engineer, they're also being able to contribute towards sort of the success of the company in broader ways. And there's an open door policy, and so these are some of the things that I want to share. That at least oftentimes, if I look at the metrics in terms of the average tenure that somebody has at Stream versus other companies, people tend to actually be here a longer time. And often people ask me, why is that the case? And that's because, I think everyone here thinks in an entrepreneurial way, and we encourage that. Because engineers themselves want to. I haven't met engineers who are like, oh, I have this great idea and I want to do something big with it. Well, there has to be a learning environment in a great company where you can walk the path with others who have done it before. And we like sharing that, and we encourage that.
Perfect. Excellent. Thank you so much. Last question. This is a question I love asking everyone. Tell us something interesting about you that the world generally does not know.
Well, Sanjeev, I some people may know, but most don't. I have a theater background, and I enjoy theater quite a bit. I've done a few, movies and some television series in the past, a long time ago, which most people don't know. And so that was a great experience, and helps you sort of step into someone else's feet and learn and understand the world from their perspective, and you can empathize better. And so that's one thing that I guess I can share that might surprise people.
Very nice. Wow. Anything we would know, like anything that's
well, I don't know. Obviously I don't have a career in the film industry.
Yeah.
but in the Bay Area, there's a theater company called Natak. They stage some incredible shows, and I've been lucky to be part of that. And one of the films that we made a long time ago was a film called Asphyxiating Uma, which is an English movie, which was a kind of a dark murder suspense thriller, and that played in the theaters for a few weeks. So I don't know if you might have heard of that, but I doubt it. But this was pre-Netflix, by the way, Sanjeev. So
I see. Okay.
Yeah, so maybe one of these days we'll go back to that, and
yes, might become a cult classic. Especially because we are recording it on Halloween day, so it's an appropriate movie for Halloween. On that note, I want to thank you so much for coming on the show. Really enjoyed, learned so much today about streaming, everything to do with streaming. Thank you so much again.
Sanjeev, thank you so much. Great questions, and it's a pleasure. You do fantastic questions, and look forward to seeing you in person at some point.
Likewise. Thanks. Bye.